Hello guys, welcome to Inside Electronics. So in today's episode I'm going to show you guys something that I found on my attic. Now this thing, the box looks pretty beat up and there is gunk over it. This is basically the rubber sealant that is used to seal pipes and things like that. This is somehow it fell over it, and the box is really beaten up, but that doesn't make that old because it is dated at 2013 and 1st January 2013. So I bought it like 3 years ago, but still, yeah. And I bought it for around 44 rupees, and it's made by Ahuja products. And by the box itself you may have predicted what's inside. This is actually a buzzer. Now the box is actually a disguise because what's inside it is something different. And when speaking about buzzers, when you hear the word buzzer, basically this is what comes to your mind: the type of buzzer that is commonly found in most electronic applications. And these are actually the buzzer that sounds like these, the high frequency. I'm covering the whole right now. If you are a headphone user, just reduce your volume or just take out the headphone because it's going to get loud. Okay, so that is what an actual buzzer, a DC buzzer, sounds like. And this is actually an oscillator, very high frequency oscillator that uses a piezo sounding element, and the working about this is a topic for another video. So these are rated for around 12 to 24 volts, the basic DC applications. And these are also used for a lot of automobile applications like the indicator sound, and sometimes these are used for the reverse sound also. You can design a lot of sounds. Now this particular buzzer is a constant voice that is continuous beeping, but you will get the different types of sounds with these kind of devices. That's happening because of a cob circuit inside. This being a very basic thing, it doesn't have a cob circuit. I will explain a video. I will make another video dedicated for this DC buzzers. But yeah, so what makes this thing different is that this thing is DC operated, this thing is AC operated. Let's take a look at what's inside. As I told you, don't let the cover disguise you, because on the cover it says Ahuja buzzers, Dong buzzers, and it says pilot buzzer over here. And what's inside is actually a Charms buzzer. And what makes it different? As this one is rated for 230 volts AC, while this thing is rated for 12 to 24 volts. And sometimes it works from 1.5 volts itself. The amplitude, the sound level will be low, but this thing works from like 1.5 volts itself. You can sometimes driven this from 2 coin cells. This thing needs serious volts. This thing reads 230. Anything above like 100 volts will make this thing work. Now this thing is not made by Ahuja, like mentioned here. This thing is made by Charms, which is also another reputable company that makes a lot of electrical goods in India. And these are basically used as calling bells, doorbells. Like, these are 230 volts bells. So instead of the regular ding dong or type of electronic bells, I opened an electronic bell made by GM in one of my episodes. You can search for it, and I will put a link in the description and also at the I button right here. So these are actually the very basic doorbells that you can get. As mentioned earlier, this thing is only 44 rupees, that is less than $1. So you are getting something that sounds really loud. Don't just think, don't miss, what is the term, I don't know. Don't judge this thing by just this, by the size of this thing. What I'm talking, because this thing is really loud. In fact, the exact one, this pilot buzzer, this exact model is what I'm using on my doorway. There is a room up there, and there is a bell in that room. So let's open this one and see what's inside. It's basically pretty simple. It uses a plastic molded locking mechanism over here. You can see 3 locking mechanisms, and yeah, that's it. That's pretty much it. All it is actually a coil and something to actually vibrate. I hope you can see that. Yeah, that is. The 2 wires go straight to a coil, and the coil has a core. You can see that iron core over there. So the operating principle of this thing is really simple. Let me draw it for you. Now you know how this thing looks in the inside, and this is the vibrating part. So let me draw how it works. So all it is basically, let me draw it this way. So if you focus on it, basically I'm sitting like that, so this is the way I'm used to drawing and writing. So that's the reason why I tilt the paper whenever I want to write something. So I cannot do this because I'm sitting in such a posture here back in the camera side. So let me draw the base. I'm going to use the blacking for this. So let me draw the base for this thing like that. So let's assume that is the base, and it has a bobbin, or however you call that, the coil, the thing that is the coil is wound on, and a core that is inside of it. And that core is what, this is the metallic part that is exposed, that is also up here. And all it is just a lot of coils wound like that, and you are applying 230 volts AC right here. So that is the way this thing works. So, and let me draw this a little bit. I'm just really sucks at drawing, but sometimes really helps if I just draw this thing. And let's say this thing is the vibrating part, so that is screwed onto the base like that. So basically let me just zoom down. I hope you can see that clearly. So basically what happens is that you're feeding this with 230 volts AC, which looks like that. Okay, let's say 2 cycles here. So this is a voltage that you're feeding this thing with 230 volts AC. So as we know that here in my area the voltage is 230 volts and it runs at frequency of 50 hertz. So what that means is that this wave completes one in a second. The amplitude changes 50 times, so the thing alternates between the positive and negative 50 times in a second. That's the basic. I'm not going to speak about that a lot. So basically what happens when you're feeding this coil with a varying voltage like that, you're actually building up a magnetic field in the coil. So when the peak voltage is reached, when the voltage at the coil is at the peak of the input cycle, the magnetic field on this coil will be the maximum, and that attracts this metallic thing to the core point, which makes it do that. We focus on it. So when the voltage is at the maximum, the coil attracts the top thing and it will pull towards it like that. And for the next cycle, what happens is that the voltage will reduce down to zero. Down to zero means there is no voltage in this coil except the back EMF going the other way. And when there is no voltage, there is no magnetic field and there is no attraction. So what happens is that this thing releases the lock, and again it goes the other way. And because this is just a coil, or what happens is that the polarity, the magnetic polarity, let's say on the positive side, let's say on this side becomes the north, and when on the negative side, the coil becomes south. Okay, so when this happens, top side of the coil becomes south, and on the positive side, the top side becomes north. So all it's happening is that when the AC goes to the positive and negative cycles, what happens is that the top of the coil gets alternate between north and south poles. But because all the magnetic field does in this case is only attracting the metallic part over there, so it doesn't matter whether it's north or south. All it does is attracting and releasing the coil whenever a 0 point is reached. So basically what happens is that the cycle pumps, it attracts with like that, and when it becomes 0 it releases again, and when it becomes the negative it also attracts it back again, and when it becomes 0 it releases, and the cycle continues. And because in a single cycle like that, a wave turns off at 2 points. if you count the initial starting point, it's 3, but let's ignore that and let's say a wave has actually two endpoints. One is right in the middle and the other is like that. So in a single wave, this thing does 2 vibrations. So what that means is that in a 50 hertz cycle, the coil, the metallic part, vibrates around 100 hertz frequency. That means in 1 second, the metallic part is vibrating 100 times. Okay, so because the 100 hertz is right in the audible range of human beings, the vibration that is created in the 100 hertz is also audible to our human ears. So that makes us listen to the sound made by this thing. That's the very basic principle that is used in these kind of buzzers, and these kind of buzzers are what also used in the old washing machines, the semi-automatic type washing machines that has the similar kind of noise that this thing generates. Let me actually turn this on for you. Now I'm saying it again. If you are a headphone user, you just turn the headphone volume down or just take it out completely, because this thing is going to get really loud. And I cannot show you whether this thing actually I cannot guarantee that you can actually see the vibration on the camera. So I have attached it and I'm going to focus on that side right there, and I'm going to plug this thing and reduce the volume or remove the headphones right now. I'm going to turn it on in 3, 2, 1. Okay, so you may have probably seen that this thing vibrates, and it was so fast that my camera was not able to pick up that one, but you can actually barely see this thing flapping around. But yeah, that is the sound that this thing makes. And if you had a washing machine back in the days, you may be familiar with the pitch of the sound this thing makes, because this was the exact mechanism that is used inside the washing machine also. If I can find a picture of that thing that I'm talking about, I will add a picture of that in the coming frame. I don't know if any picture of that particular thing is available, but if it's available, you will see the picture right now on the screen. And the only difference between that one inside a machine and this one that is used as a bell is in the washing machine system. Let me take this out of the screen. In the washing machine system, it had a knob on top on which you can adjust the volume of that thing. And basically what the knob does is it adjusts the position of this metallic thing closer and away from this. So when you turn it tight, the position comes closer, and that changes the pitch of the sound that is produced, and that basically reduces, because the vibration has lot less room to pressurize the wave around it. The sound will be much lower, and when it is fully open, it has much more room to actually push the sound wave away from it, so that actually makes a much louder sound. And basically when you're turning the sound all the way off, all it does is it makes this thing pushed towards it, so no matter what the coil voltage or the magnetic field is, this thing cannot move at all. So when the sound is, this thing actually is powered, but there is no sound made. So yeah, that's basically how an AC buzzer works, and you may now know about a little bit more about how different kind of things work. So I do have a lot of other things that I found in my attic which are still in its box. I will show them in the coming videos. But by the way, I hope you understood how everything works. If you have any doubts, you can ask me in the comments below. And I hope I covered everything. And yeah, that's it. That's how an AC buzzer works. By the way, this thing is really good to use, and for 40 rupees. And let me do something. Don't just go away. Let me just measure the resistance of the coil. I'm going to find my multimeter and I will be back. Okay, so here is a meter. So I'm going to now attach the coil to the multimeter leads, and I set it to 2000 ohms range. So where is my other lead? Yeah, there it is. I'm going to plug the lead in and let's measure the resistance. I hope you can see that it is 760 ohms. This coil resistance is 760 ohms. So let's measure the current flowing through the meter. Let me just, okay, so I'm going to do it. Here in India it's 230 volts, so well, how can I do it? Yeah, let me see. 230 volts divided by the I is V over R, so 230 ohms divided by the 750 ohms. 750 ohms is equal to around 30 milliamps. Sorry, I mean 300 milliamps. So yeah, 300 milliamps current, that is how much power this thing consumes. So the power consumption is P is equal to VI, that is I is here, so this thing multiplied by 230 volts is around, no, that's not good, that's 70, like I don't know, but anyways, let's forget. I'm really bad at maths. Anyways, 300 milliamps is current that this thing draws. Yeah, anyways, thanks for watching. See you in another video.